current induced by changing magnetic field. How is electricity made? Electricity can be made using batteries or dynamos, also called generators. What energy transformation happens in each case? In the case of a battery, chemical potential energy is converted into electrical potential energy. In a dynamo or generator, such as at ESCOM, kinetic energy is converted into electrical potential energy. For example, steam might make a turbine spin, which generates electricity. But how? Well, in the case of a battery, there are chemicals inside the battery, and chemical reactions happen at each of the two terminals, causing them to become differently charged, setting up a potential difference relative to one another. In this way, chemical potential energy is converted into electrical potential energy. In a dynamo or generator, there is some kind of mechanical input, some input of kinetic energy. This might be steam rising and spinning a turbine, or in the case of a bicycle dynamo which powers a bicycle headlamp, it might be your feet pushing on the pedals which turn the wheels, which turn the coil of the dynamo. The kinetic energy is inputted and it rotates a coil that is within a magnetic field. And as that happens, electricity is generated because the coil experiences a change in magnetic field. And this process converts kinetic to electrical potential energy. Whenever a conductor and a magnet are moved relative to one another, electricity is generated in the conductor. Ways of doing this include that the conductor could be kept still and the magnet moved, or the magnet could be kept still and the conductor moved. In the first diagram, the solenoid has no current in it, since it's not experiencing a changing magnetic field. Although there is a magnet nearby, the magnet is still, it's stationary. The magnetic field around the magnet is also stationary. So although the solenoid does experience a magnetic field, it doesn't experience a changing magnetic field, and therefore the charges inside are just still. They don't move. No current, no voltage induced, no current present. However, in the second diagram, the magnetic field that the solenoid experiences changes over time because the magnet is thrust towards, in this case, the solenoid. And as a result of that, the solenoid experiences a change in magnetic field, which induces a current in the wires. Kinetic energy from the motion of the magnet being thrust towards the solenoid is transferred across to the solenoid, and it's converted into electrical energy. Another way of inducing current in a solenoid is shown in the bottom set of diagrams. Each of these diagrams shows two solenoids, one connected to a battery and one not. The one connected to the battery is called the primary, and the one not connected is called the secondary coil. The secondary coil has a galvanometer, and this is to detect whether there is any current or voltage induced in it. In the first diagram, the switch is open in the primary coil, and therefore there's no current flowing in the primary coil. Therefore there's no magnetic field around the primary coil. Therefore the secondary coil does not experience either a magnetic field or a changing magnetic field from the primary. Therefore no current is induced. The reading on the galvanometer is 0. However, closing the switch in the primary leads us to the diagram 2, in which we do have current now flowing in the primary coil. And as this happens, this establishes a magnetic field around the primary, and therefore in the region of space occupied by the secondary. And this magnetic field grows from not being there at all through to its highest strength sometime later. And during this period of change of magnetic field around the primary coil, then the secondary coil, which is located within the influence region of the primary coil's magnetic field, experiences this change in magnetic field, for example, as the field grows from nothing until its strongest and therefore furthest influence. And during this period of change of magnetic field around the primary, the secondary coil, experiencing a change in magnetic field, experiences current induced in it.